In this video, we're going to take all of the information about our three amplifier configurations and we're going to summarize and kind of compare and contrast about their capabilities. So we're going to do this using a table which has been adapted from table 6.4 on page 435 in the textbook. But personally, I think that the table shown here is going to give a bit of a clearer picture about what's going on. So as you can see, we have our three basic types. We have our common emitter in the first column, our common collector, also known as our emitter follower, and then our common base in the third column. Some key things that we're looking at here are voltage gain, current gain, input resistance, output resistance, where the input is at, and where the output is at. So with that in mind, let's start first by looking at our voltage gain and noting that we're talking about magnitudes here. So for instance, for our common emitter, we saw that we had a magnitude of our voltage gain greater than 1. Of course, it was a negative value, but again, we're just considering magnitudes. We said for our common collector, the voltage gain was approximately 1, a little bit less. And for our common base, we saw that we had, again, a greater than 1 voltage gain. For our current gains, we saw that both common emitter and common collector had current gains greater than 1, where our common base had a current gain that was approximately 1. And so what we see then is for all three of these configurations, we have some small signal power gain. So we don't have a case where both voltage and current gain are approximately 1 for the same configuration. Now, our input and output resistances are very important when we consider our loading effects and what type of input signal and what type of output signal we have. For instance, is it going to be a voltage or a current? So for our common emitter, we said we had moderate input resistance. Common collector, we have high. And for our common base, we have low. And so we notice we have sort of a little footnote for our common emitter and common collector. So we have this little footnote symbol here. And so what we see is that for that input resistance of our common emitter and common collector, it's highly dependent on our bias circuitry. And so if we're talking about voltage divider biasing, then that means that input resistance is going to depend on our R1 and R2 values. All right, so moving on then to our output resistance, we see that we have moderate to high for our common emitter, low for our common collector, and again, moderate to high for our common base. And again, we have another footnote here, and what this says is that for our common emitter and for our common base circuits, this is a strong function of our collector resistor, R sub C. So all of that, whether it's high or, more on the low end, could change pretty drastically just depending on what RC value we use. So that's important to keep in mind as we're designing these circuits and considering loading effects. And then the last two columns are just talking about where our inputs and outputs defined. So for our common emitter, we have the input at the base and the output at the collector. For our common collector, we have input at the base, output at the emitter, and then finally for our common base, we have input at the emitter and output at the collector. And so of course, when I'm talking about inputs and outputs, I'm talking about our small signal inputs and our small signal outputs. And of course, the third terminal that's not mentioned is the one that is common or at signal ground.